April should be on my calendar. Something. Is it 9? Yeah, April 10th is the SAT.
April the 10th. Okay.
Yeah.
So our last session is going to be on April the 7th, correct?
Yes.
Let me cancel everything after that so I get my calendar straight. Okay. Now, my notes say that we got through test 2, number 7. Let's see, we're going to probably have 4 sessions. We might be lucky to get through test 2. We might not
Okay.
completely through test 2, but
Okay.
that's okay. We're certainly getting a good exposure.
Mm-hmm.
All right, so we left off with number 7, which had a lot of parts to it, which is what we're finding all of these questions do, is they all have a lot of parts to them.
Yeah.
And so we needed to know that you subtract the exponents. So you had a squared minus b squared equals 16. And then you needed to know how to factor difference of perfect squares, which was a minus b times a plus b. And then they told you what a plus b was. So relatively easy to solve for a minus b.
Yeah, I remember that. Yeah.
Still, there were a lot of steps to it.
Yeah.
Number 8. What's the rule for the sum of the exterior angles of a regular polygon?
Sorry, what was the last part you just said?
What's the rule for the sum of the exterior angles? An exterior angle means this. If you were to take all of those angles,
Yeah.
what would they add up to? Now, hold on. I haven't quite finished. That angle,
Okay.
that angle, that angle, that angle, that angle, that angle. What do they add up to?
360.
Correct. That's the principle here. They add up to 360. Now,
right.
You can see that that's kind of what that first formula says. The number of angles times the measurement of each angle equals 360. That's what that means. Okay. So.
And then, and the triangles are 180.
That's correct. Although that really doesn't have anything to do with this problem. But that's an that's an important fact for sure to remember. So this says if the measure of an exterior angle is greater than 50 degrees, what is the greatest number of sides it can have? Where are you going to start here? You're going to start where? In other words, first of all, we're going to back solve it. All right? We're gonna substitute the answers and see if they could make sense, whether they qualify or not. Well, where are you gonna start?
Right. Well, I'm gonna go back up to the equation NA equals 360, and then so it says n is the number of sides, so I can substitute in one of those numbers for n, and then I can solve for a.
There's the key word right there. What's the greatest number of sides it can have? So where am I going to start? If I'm going to take my answers and substitute it, where I'm going to start with the largest number, not the smallest number, not the second largest. Let's start there.
Okay.
Can it have 8?
This is a non-calculator, right?
Yes, that's correct.
Okay.
You don't need a calculator anyway. What you need to do is this. What's 8 times 50?
Yeah. No, that. Yeah. That. Yeah, that won't work.
Really? What's 8 times 50?
400.
Okay. Has to equal 360 or less.
Yeah.
So that doesn't work.
Yeah.
In other words, 400 degrees is too much. So we can cross off that answer. Now, the way to proceed is the next largest one. Can it have 7 sides?
Yes, it could.
Yeah, 7 times 50 is 350. So it's all it says is the angle is greater than 50 degrees. So it could be 51 degrees, it could be 50, couldn't be 52, but it can be 50 or 51 or anywhere in between. So that's the answer, okay? Now, do you see why we started with D?
Yes.
In other words, had we started with A, and yeah, that works. 5 times 50, that's 250. That works. But now we got to try C, or rather B, because it says what's the greatest. So we got to
Greatest number, yeah.
And it would only be after we tried all 4 answers that we would discover our answer. You know, C is 7 times 50. That works. But if we begin in the wrong place, then we have to do a lot more calculation. So when you see things like greatest number and you're going to solve it with back solving, then start with the greatest, not B or C. There are a lot of back solving problems where you should start with the second lowest or the second highest, but not in this case. In this case, had I started with 7, yeah, that works, but it wouldn't rule out 8. So I would have to try 8.
Right.
So when you see keywords like that, start with the greatest. If the question says, what is the smallest? Start with the smallest. All right. Still no calculator. Number 9. Easy, medium, or hard? Actually, when I say that, what I really mean is, do you know how to solve this? Are you not sure if you know how to solve it? Or are you sure that you don't know how to solve it? That's really what I mean. Because if you know how to solve it, then solve it. If you're not sure, then put a check mark by it. Label it medium, maybe. You know, put an M and come back to it.
Okay.
What would you do here?
Probably M, medium.
Okay. First of all, let me have a look at it. Yeah, it's complicated enough. Even though there's 5 sentences, and I said the more sentences there are, the easier it's going to be, this is relatively tough. But that doesn't mean we shouldn't go through it. We should. Okay? So what's the first thing I should do?
Use the equation y equals mx plus b.
Draw a picture.
Oh, okay.
In other words, when they're giving you questions about the XY plane, then go ahead and draw pictures. In other words, I'm going to put an XY coordinate grid on there. And it contains the point 1, 8. So I know that point is on there.
Mm-hmm.
And by that I mean that point is on my line, the graph of a line. Now, if it has a slope of 2, what other point is on? Well, I'm not even sure we need that at this point. Yeah, let's put another point on there. So how do we get the y-intercept?
So you can you use the equation to solve for y?
No, apply the slope. A slope of 2 means it's a rise of 2 and a run of 1. So what point would this be if it's got to have a rise of 2 and a run of 1?
So rise of 2.
In other words, you got to kind of work it backwards. What gives you a slope of 2?
Yeah. So the point would be 6, 0?
Almost. 0, 6.
Oh, yeah.
Right? All right. So that's our first line. Now, I don't even know if I needed that y-intercept, but that was the easiest point, the second point to find. And now it says the graph of a second line passes through the points 1, 2, which is right there. Notice I'm just approximating. I'm not gridding up this XY thing. If you do that, you'll run out of time. You do not have time to draw a grid on here. The only way to answer these problems is by approximating, because you speed things up when you do that. Okay? And it also goes to point 2, 1. That's like right there. Now, draw that line. If the two lines intersect at A, B, that's this point right there. What is the value of A plus B? Okay, all of a sudden this got to be really hard instead of just medium. Let me think about this for a second. Well, you know the point slope formula? As opposed to the slope-intercept formula?
I don't have it memorized, but yeah, I have used it.
Well, you kind of need to memorize it.
Okay.
In other words, we know the red line has the following equation, which is, here's the point slope. Y minus y1 equals the slope times x minus x1. And the reason I want to use this one is because we don't have a y-intercept on the blue line. Because all we have is a point, and we can figure out the slope. We didn't, but we can certainly figure out the slope from those 2 points. Okay? And that's going to allow us to get some information about A and B. Okay? So, the first one, let's use this point right here for the red line. So that's a y minus 6 equals, we know the slope is 2, times 1 minus, or x minus 0. See how I got that?
Yeah.
Okay, so that gives us y minus 6 equals 2x. That's the equation of the red line. Now, the equation of the blue line is, we'll use this point, y minus 2 equals, well, the slope, we don't know the slope, but yes, we do. It's 2 minus b divided by 1 minus a, right? It's rise over run. Times x minus 1. So that's the equation of the blue line. That's the equation of the red line. What we have to do is set them equal to one another, and then we can maybe discover things about A and B. So I'm going to take the first line and I'm going to add 6 over here. Now I know what y is equal to. I'm going to take the second equation. I'm going to add 2. Now I know what y is equal to. And because these two lines intersect, I know that the y's are equal to one another. So now I can say 2x plus 6 has to equal 2 minus b over 1 minus a times x minus 1 plus 2. Now, here's an equation, and they're asking me about a plus b could be equal to. Wow.
There's a lot of steps for this one.
There's more than a lot of steps. I'm not even sure I'm taking the right ones. It's difficult to even back solve because you see a question that it's asking about the sum, difference, product. That's not one you want to back solve. What you'd want to back solve is, what's the value of A? Well, then I can plug in that and maybe make some progress. But what's the value of A plus B? This may be one of those that I have to think about before being able to answer. Or come back to at our next session. It seems at this point that I might be able to do a little back solving to see if this equation makes sense.
Okay.
In other words, first of all, I might simplify this. So I had 2x plus 4 equals 2 minus b over 1 minus a times x minus 1. So I would start from there. And then I guess I would see if I could simplify, get rid of the x's, and figure out what a plus b was equal to. I don't know. I could also start substituting more. That's going to be hard to do too, because they're asking about sum. So I would almost have to do the algebra here. See if this advances the thing at all. Boy, I'm at a loss. It's rare that I'm at a total loss when I'm doing an SAT problem. I guess let's come back to this instead of spending more time on it. In other words, and that's definitely what I would suggest that you would do when encountering a problem like that. That's going to be one you're going to end up guessing on, most likely.
Okay.
So, you know, if you see a problem and you're just completely clueless on it, then it might be correct to go ahead and guess at that point. Just so you don't have to spend your precious minutes, you know, when they give you the 5-minute warning. You don't want to have to go back and guess on a problem that you know you're going to guess at the first time. Now, if you go ahead and guess on it the first pass through, that doesn't mean you know, if you end up with extra time and you go back, you can still look at this problem and change it. You're not stuck with your guess. In other words, you are allowed to go back and erase and change your answer, you know, as long as you still are before they say pencils down.
Yeah. Is it, I mean, would that be like maybe one where just hopefully draw the graph as accurately as you can and then go and then take a guess from there?
I'm a little bit at a loss on this problem. No. Minus 1/2. Here's what we got going on. I just saw it.
Okay.
I didn't see this before. I'm not sure it's going to help, but I bet it does. There's our first line. What's the slope of our second line?
2 minus a over 1 minus b.
No, the second line passes through those 2 points. So we know what its slope is.
Yeah.
It's minus 1/2. Remember, it's y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. That's rise over run. That's the rise. That's the run.
Yeah.
Well, the slope of the second line is minus 1/2. And the key thing is that makes it perpendicular to the first line. If this has a slope of 2 and this has a slope of minus 1/2, they are perpendicular.
Okay.
That's a key thing to remember. You remember you spent a year in algebra learning that. That if 2 lines, if the slope of one line is the negative reciprocal. In other words, if I tell you the slope of that line is 2, and then I tell you there's a line that's perpendicular, then I know the perpendicular line has to be negative 1/2. You have to do 2 things. You have to change the sign, and you have to reciprocate it. So always remember that you have to reciprocate it and change the sign.
Okay.
Now, that means the second line, slope, I know it's -1/2, which I didn't know before. And I know that that's equal to 1 minus b all over 2 minus a. So I know that's true. And believe it or not, that's going to allow me to work out what a plus b is. I'm going to multiply both sides by the denominator. Here's what I get. -1 plus a over 2 equals 1 minus b. Now I'm going to multiply both sides by 2. -2 plus a equals 2 minus 2b. A plus 2b equals 4. I feel like I've found the correct path, but I may have made a mistake in my math. Although I don't see it, it seems like I can get to that step pretty easily once I have the slope of the second line. Because I know point AB is on that line. Once I get to that point, I suppose I could kind of back solve it from here. In other words, this can't be possible, can it? For a plus b to equal 4, not if a plus 2b equals 4. But this could be possible. Negative number, a plus b, I don't think that can be negative either. So I feel like the answer has to be 3, but that's even an educated guess. But
yeah,
you can be.
But yeah, we can bet on it.
Well, you can kind of see that, man, depending on the path you take to solve these more difficult problems, you can spend 15 minutes off in the woods in the wrong direction, like I did the first time through. I feel like my second pass through, where I used those 2 points to figure out the slope, now I know it's perpendicular, and now that tells me quite a bit. But even that didn't get me the answer. So again, let's go on. I'll come back to this next time we meet.
Okay.
I'm going to be interested to see how this solves anyways.
Okay, sounds good.
Let's go to 10. It definitely gives us information as to where we're at on the test. We are no longer in the easy problems.
Oh, very true.
Hold on a second. All right, number 10. Before I ask you if this is easy, medium, or difficult, let me ask you how you're going to solve it.
Yeah, I'm thinking.
Because once you figure out how to solve it, that tells you whether it's easy, medium, or difficult.
Right. I'm thinking. Let's see. Which is I'm thinking like draw a picture, and then start with.
Try to back solve.
Okay.
In other words, and I don't know where to begin, but I also don't know how to solve the problem. A picture probably is correct of each of these functions. In other words, let's start and see if that's true. Remember, it always has to be greater than or equal to minus 1.
Mm-hmm.
So, if we go to draw that, first of all, the absolute value function looks like that. That's y equal absolute value of x. But what's the consequence of that minus 2? It's a vertical shift down by 2 units.
Oh, that's just it. Okay, yeah, I got you. Yeah, all right.
Okay. So this is the blue function is a. Now, is y always greater than or equal to minus 1?
No.
No. It's minus 2 right there.
Yeah.
Probably less than minus 1 there. It's less than minus 1, but all I have to do is find one point that's minus 2. So that's not the answer. And by doing a similar thing, we will figure out what the answer is. It's just going to be tedious. So this problem isn't hard, but you do have to know how to graph your functions. How do I graph B? What kind of function? Is that a straight line? What is that? Y equal x squared.
No, it's a parabola, isn't it?
Correct. And what's the consequence of the minus 2?
Shift down 2.
So it's a parabola like that. Again, we have a y right there that's minus 2.
Yep, so nope.
X minus 2 squared. Well, what kind of shape is this?
Still parabola.
Okay. And what's the consequence of the minus 2 inside the function? Or
Shift to the right 2.
Yeah. So now we have a parabola that does this. Is that the answer?
Yes.
Are we done with the problem?
No.
Actually, we are.
Yeah.
Because and we can see visually that that's correct. There is no y value there that is not greater than minus 1. Okay? So they're not going to give you 2 correct answers. So we found an answer that works. And it says always greater than. Well, they can't give you 2 correct answers. So if D works also, they've screwed up. And
Yeah.
D is just a cubic that's been shifted down by 2 units. So D would look like that. So you could take the trouble to graph it and realize that there's all kinds of points that are less than minus 1. So you'd rule out D pretty quickly. But notice the common thread here, that if you were really sharp, you would notice that, that, and that are all vertical shifts, which rule out all 3 answers. Because when x is equal to 0, what is y going to be in all cases? What's y when x equals 0 right there?
Y is equal to -2.
What's y when x equals 0 right there?
-2.
And what's y when x equals 0 right there?
-2.
That rules out all three answers. And in fact, you could solve the problem by doing that, and that immediately, and knowing that that has to be correct. And the reason this is correct is because this is a horizontal shift. It's not a vertical shift. So when I say when x is 0 here, y is +4. So there is no value of x that makes y negative. You know, I mean, you could solve this in a number of different ways. The most useful way is to know that it's a horizontally shifted parabola and that every y value on that is positive. So every y value is definitely greater than or equal to -1.
That's true.
So that was a lot easier than the last problem for sure. At least in my way of thinking. When I go back and figure out that last problem, I may see something that I just didn't see the first time. And it may not be as hard a problem as I'm discovering it to be, number 9. But let's look at number 11. And let me say one thing about number 11. When they give you imaginary numbers, it's an easy problem as long as you know your complex number rules. And there's not very many of them. And they're easy to memorize. Okay? You don't really have to know what I is. So the fact that they give you that is kind of immaterial. Or irrelevant.
Right.
Okay? What you need to know is how you handle a division problem with complex numbers. Let's go back a step. If I give you a number like that, is that a division problem?
No.
No, it isn't. How are you going to solve it? The problem is you have an irrational denominator, right?
Yeah.
You got to turn it rational. And the way you do it is by multiplying the top and the bottom by the same thing. And you end up with the square root of 2 in the top and 2 in the bottom. That's a satisfactory answer. But my point being is that just because it looks like a division problem doesn't make it a division problem. And that's definitely true with complex numbers. That's not a division problem. It's a multiplication problem. Question is, what am I going to multiply it by? The top and bottom by the conjugate of the bottom. Conjugate means the same two terms, different sign.
Okay.
If that was a negative sign on the left, it would be a positive sign on the right. Now, I'm allowed to multiply any fraction by the number 1. So I have to make sure I do the top and the bottom by that.
Okay.
And what this has as an effect is it turns the bottom into a real number. Notice all of our answers have the bottom as real numbers. And that's why you do it. For the same reason they don't want you to divide by an irrational number, they don't want you to divide by a complex number. And the way they do it is by having you multiply out. Now, if you do the multiplication, again, let me write it further to the left so I can have room to write. Every time you see a division, every time you see a divisor that is a complex number, think of it as an irrational number where you have to rationalize it. Only I don't call it rationalizing it, I call it realifying it. Because that's what you're doing, is you're making the denominator a real number. Now,
Okay.
if you FOIL those two terms together, what you get is 64 minus 4i squared. Well, now that comes into play. What is I squared equal to? If I equals the square root of negative 1, what is I squared equal to?
1?
Negative 1.
Like, oh, because again, yeah.
Multiply I times I. You have negative 1 times negative 1. I mean, excuse me, the square root of negative 1 times the square root of negative 1, that gives you negative 1.
Okay, yeah.
Well, if I substitute negative 1 for I squared, I end up with a denominator of 68. That is a real number. Okay? Now, all we got to do is FOIL these two terms. Well, I'm going to FOIL it just like I would FOIL anything. 24 minus 6i minus 40i plus 10i squared. There's that I squared again. For I squared, anytime you run into an I squared, you can substitute negative 1. I'm going to combine that with that. I'm going to get 14. I'm going to combine those two terms, so I'm going to have minus 46i, and my denominator is 68. Well, now I can simplify that a little bit by dividing top and bottom by 2, which gives me 7 minus 23i all over 34. What does that look like? That answer right there.
Okay, yeah.
7 minus 23i all over 34. In other words, that's not exactly the same, but it has a common denominator, so I can add or I can operate on the numerators. That's the same as that.
Right.
Again, this was kind of encapsulated all aspects of complex numbers. If I was going to teach a course, let's say a 1-hour seminar on complex numbers, this would be the perfect problem.
Okay.
Because it shows you how to handle it when it's a denominator. It forces you to deal with I squared, which is minus 1. And it forces you to simplify it by dividing top and bottom by a number if you can. And notice I can't simplify any further. If I could simplify further, that wouldn't be an answer. But they merely take the answer down to its simplest form.
Yeah, that seems.
These problems are tough. We've got to be getting to the end of the section pretty soon, I would think. Just because, yeah, no, we're nowhere near. We're still in the middle section. This shows you that it's not always what you or I would necessarily think was easy, medium, hard.
Right.
Clearly, we're running into some tough problems here.
Yeah.
This is not one of them. Well, this is an algebra problem. Always remember this. the SAT is, the math portion of the SAT is very heavily flavored towards algebra. Very,
Yeah.
much more so than ACT. ACT
What is
is
the answer?
pretty much of a blend between algebra and geometry with a few trick
Okay.
questions. SAT is 80% algebra, 15% geometry, and a couple of trig questions. ACT has 4 trig questions. SAT might have 2 or 3. Okay? This is algebra. Okay? They're giving us an equation that's solved for R, and they're going to ask us to solve for one of the other letters. Obviously, they want us to solve for F.
Yeah.
So you need to
Oh,
be
it's just like switching around the variables, isn't it? Yeah. Okay.
you need to be able to do this. If you don't know how to do this, let's go through it in detail because, like I said, algebra is 80% of the test.
No. Yeah. I think I know how to do it. I was just saying. So
Me
just look. It just looks like they're wanting you to like switch them around.
Well, work me through
So
it. What's first step?
okay.
There's kind of a rule I have when solving algebraic equations. Get rid of your denominators and your parentheses. We don't have any parentheses, but we certainly have a denominator. Let's get rid of it. How do I get rid of it?
Multiply by the reciprocal.
No, multiply both sides by it. If I multiply both sides by the denominator,
Okay.
it's going to get rid of it, right?
Yeah.
And that cancels with that. Now I'm left with that equals F, but that's not the answer because I still have an F on the left side. So what's the next? In other words, now I have this, in case it's not that clear. In other words, that can't be an answer for F. When you are solving for a variable, you have to get it isolated all by itself and have none on the other side. Well, I still got an F over there. So what's the next step? Get rid of parentheses. What'd I say? Get rid of denominators, get rid of parentheses.
Yeah. Multiply everything by everything.
Okay, so I have R times N plus F times N, excuse me, F times R equals F. Now what? Now I got no more denominators, no more parentheses. This is the
So you can.
this is the toughest step. Combine
So
like terms.
yeah. So because
Put everything else on the other. It's real simple, actually. Just combine anything that's got an F in it. Since I'm trying to solve for F, anything that's got an F in it, let's put on the left side, and let's put everything else on the right.
okay.
So what's the left side become?
2FR.
No, just write it as you see it. FR minus F equals minus RN, right?
Okay. Yeah.
In other words, I took these two terms, I put them on the same side, and I put everything else on the other. Now, what can you do? You're trying to solve for F. Well, I got a couple of F's over here. How can I get F all by itself?
Get rid of R. Well, no.
Factor, factor, factor. Always be thinking factoring. When you don't know how to do something, think factoring. Can I factor it? Can you factor out an F?
Yes.
Okay, what do you get?
So F from the outside, then R equals.
When you factor out an f, you have to divide both terms by f. That's
minus.
multiply and then in the moment you do that, you should multiply those two back together again and make sure you have what you started with.
Okay.
And you do. In other words,
Yeah, you do.
fr minus f. And that's all equal to minus rn. And now the solution becomes apparent. I'm going to divide both sides by that. And that leaves f all by itself and no f on the right side. And do we see that answer?
Yes.
No, we don't.
You don't?
Well, we see an aberration. And this, again, is just another algebraic principle that they're trying to teach you. The more we do this, Ben, the more I'm beginning to believe that this is not a true representation of the SAT test you're going to take. What it's designed to do is to cover every single algebra principle that you need.
Okay.
Okay? We don't see this answer. See that answer? That's close. Doesn't have a negative sign. We see that answer. That's close. Doesn't have the negative sign either, but it reverses the denominator. Well, guess what? A minus B equals the negative of B minus A. Very important algebraic principle.
Oh.
So this 1 minus R, I could write as the negative of R minus 1. That's the same thing. And now that is the same thing as we got. It doesn't matter whether that negative sign is in the denominator or the numerator. In this answer, it's in the denominator, but same answer in the numerator. So B is our correct answer. Again, a wonderful problem to test your algebra skills and your knowledge of that. Now, let's just review that for a second. If I said to you, what is the answer to this? What is it?
So, B, first that was x minus 3. So, 3 minus x equals x minus 3?
No, not equals. Don't do it that way.
Or divided by.
Well, actually, that wouldn't be a bad way to do it. In other words, yeah, you're right. Well, no, because I have a question mark there. So I can't multiply both sides by 3 minus x. That doesn't work. The point is that 3 minus x is the same as minus x minus 3. That's 3 minus x. Now if I have x minus 3 in the numerator, I can cancel those two. And what do I have? Negative 1.
1, yeah. Okay.
So always know that when you see that, it's negative 1. Or when you have a negative sign that you don't want, then, and you're looking for an answer, well, notice that that's negative R minus 1. Again, these are tough, they're tricky, but I think they're designed more as training than they are as representative of the test. I really do.
And it's got you just gotta know all the rules.
There's just so many steps to each of these problems. And we're in the midsection. There's no way a medium hard problem is going to have every principle and imaginary numbers built into it. And yet we've seen that they do. So. Number 13. Let's see if we can, we may not have time to do 13. I tell you what, let's end on 12, just because we have some very heady problems here today. It's no point in extending the complexity any more than that.
Yeah, true.
We'll pick up with 13 next time.
Okay,
sounds good. All right, Ben. I'll talk to you next Saturday. Bye-bye.
All right, great. Thank you. Sounds good.